We've looked at water a number of times in this class, so by now I'm sure you've realized that water is made up of 3 different atoms, 2 hydrogens, hanging out like Mickey Mouse ears, attached to an oxygen atom. And we say that these atoms are bonded to each other, forming a compound or a molecule. But the question I want to explore now is, well, why? Why do 2 hydrogen atoms and an oxygen atom snap together like this? What's going on? To answer this question, we actually need elephants. The reason we need elephants is because we can't see atoms. So understanding what makes an atom do what it does is really hard because we can't visualize it. So we're going to use the elephants as an example. Just try and keep in mind, atoms are not elephants. We're just using them to help us understand atoms. All right, here's a question. Which one of these elephants do you think is the most stable? By stable, I mean an elephant that is mostly at rest. It's not using a lot of energy. It's not in a situation where it's going to fall over. Which of these elephants does that describe? I think it's pretty clear that the most chill, relaxed elephant is this one. It's already on the ground, so it can't really fall over. It's obviously not using much energy to maintain that position. That's a nice, stable elephant. Which elephant is the least stable? Which elephant is in a situation where any minute now it's going to come crashing to the ground and it's having to expend lots of energy to maintain that situation? I think it's pretty obvious. This elephant is very unstable. It's easy for we humans to see when something this big is in a stable or unstable condition. But we can't see atoms, so it's hard for us to understand how stable one atom is versus another atom. So to help you, we're going to use these elephants to help us visualize how stable one group of atoms is compared to another. And this is important because the reason that water forms a molecule, the reason that hydrogen and oxygen atoms snap together and bond, is because they're becoming more stable when they do that. So it's the same thing that makes this elephant down here in the corner fall to the ground. It's because that's an unstable condition. It has to use a lot of energy to balance against gravity. So the minute it gets the opportunity, that elephant is going to come crashing to the ground. Atoms do the same thing. They bond in order to get out of these uncomfortable, precarious, unstable situations that they find themselves in. So if laying on the ground is stability to an elephant, which atoms are like this elephant? Well, it turns out it's the noble gases. Over in group 18 of the periodic table, the noble gases are completely stable. And the reason for that is that they have full valence shells. For some reason, atoms are very stable when they have all the electrons they can possibly fit crammed into their outermost shell. And for most atoms, that number is going to be 8. It's going to be 2, however, for the few small atoms that are in groups or periods 1 and 2, like helium. Having a full shell means being stable. It means that that atom has no reason to bond because it already has a perfect situation. It's totally at rest. It's laying on the ground. The most unstable elements on the periodic table are in group 1. They only have 1 valence electron. This is very unstable. It's like being an elephant balanced on your trunk. And it's so unstable that in nature you don't find any of these elements by themselves in the elemental form. Just like you don't find elephants balanced on their trunks, you're not going to dig into the earth and find some pure lithium or pure sodium or pure potassium. All of the lithium, sodium, and potassium that's out there in the world is usually bonded to some other atom. So you might pull lithium oxide out of the ground or sodium sulfide. But we can separate them in the lab using chemical reactions, and then we can keep them separated by storing them in something that doesn't chemically react with them. So all 3 of these in the bottles up here are stored in mineral oil because the minute you take them out into the air, they start to bond with things in the air. If you put them in water, they burst into flame. And we'll do some of this in class. in order to experience for ourselves the dramatic amount of energy that can come from an unstable atom bonding. And that's really why atoms bond. Sodium will bond in order to become more stable. Just like this elephant will fall over and go to the ground as a natural consequence of the fact that it's really hard to balance against gravity like this. The group 2 elements have 2 valence electrons, so they're a little more stable in this condition. They're like elephants balanced on a ball. If you push the ball out from under this elephant, he's definitely going to fall, he's going to release some energy, but you got to push the ball out from under, right? He's not just going to automatically fall unless he happens to lose his balance. That's pretty much the deal with the elements in group 2. You can find them alone in nature, but you don't very often find them alone in nature, just like it's pretty unusual to find an elephant balanced on a ball. We've seen some of these in our classroom. In particular, we looked at magnesium, and you see that you can push magnesium to bond with the oxygen in the air. You just have to give the magnesium some heat energy. That's the equivalent of pushing the ball out from under the elephant. When you do that, the elephant falls down, releases a lot of energy as sound, and also as, it deforms the ground and the elephant. But when you heat magnesium, it releases energy as heat and light. Calcium is another group 2 element that is very reactive. As soon as you put it in water, it starts to bubble and fizz and turn into calcium hydroxide and calcium oxide. This should make you realize, if you've never realized before, that calcium is not what makes up your bones. Your bones are compounds of calcium, like calcium carbonate and calcium phosphate. Pure calcium would not be very useful to make bones out of because, as you can see, calcium is a very unstable atom. It's an elephant balanced on a ball. It will react chemically and bond to pretty much anything. Being somewhere in the middle of the periodic table between groups 3 and 12 is fairly stable. Not as stable as laying on the ground. You do bond if you're in this part of the table. You just don't do it as easily. It takes more energy usually to get you to bond than just kicking a ball out from underneath this elephant. This elephant, we've got to topple over with a little more effort. Once we do, we'll get plenty of energy out of the system, and the elephant will be more stable because it'll be on the ground. But these elements are fairly stable compared to the other 2 groups we just discussed. And finally, the halogens in group 17 are pretty unstable. You might think that they should be stable since they're so close to full, but they're actually, having 7 valence electrons actually is a lot like an elephant trying to balance on a ball on just 1 foot, which is even more precarious and unstable than the elephant we had with 4 feet on the ball, which was like the group 2 elements. So this is a pretty unstable situation. So when I see you in class, we're going to practice this idea of identifying different atoms as stable or unstable based on how many valence electrons they have. And then after that, we'll start talking about how exactly atoms go about becoming more stable through the bonding process. See you in class.